Hi, this is Pruthvi. Today I am going to present CS536 bonus project, which is about intrusion detection system. My main motivation of this project is to develop an intrusion detection system with machine learning such that it will better predict the intrusion with fewer false positive rates than the traditional intrusion detecting systems. Okay, let me share the screen and talk about the presentation as well as the code. So this is basic outline of my presentation. And first thing is the network security. Network security refers to the set of activities, processes, and technologies that were implemented to protect computer networks and their components from various types of attacks and threats. These may include unauthorized access, use, modification, restrictions, or disclosure of data, as well as the interruptions in network services. To ensure network security, organization may employ a variety of security measures such as firewalls, intrusion detection systems, antivirus, etc. For instance, firewalls are used to monitor incoming and outgoing network traffic and prevent unauthorized access to the network. Intrusion detection and prevention systems are designed to detect and prevent attacks that target specific vulnerabilities in the network. Next is intrusion detection system. An intrusion is a powerful illegal attempt, whether it is successful or not, to enter, access, manipulate, or use appropriately any valid property which may cause the property to become unreliable or useless. An IDS is a security tool for detecting unauthorized intrusions into computer systems and networks. Here we can see the host system is connected to the internet via router and there is a firewall and IDS in between. As I told earlier, firewall monitors incoming and outgoing network traffic and IDS is used for detecting unauthorized intrusions into computer systems and networks. And next is IDS with machine learning. IDS with machine learning is enhanced version compared to the traditional IDS techniques. IDS with machine learning combines traditional IDS capabilities like log analysis, response and alerting, and signature-based detection with machine learning algorithms power to improve threat detection and response accuracy and effectiveness. Machine learning algorithms can be trained on large dataset of known threat patterns to automatically detect new and emerging threats that may be difficult for the traditional rule-based IDS. Moreover, ideas with machine learning can detect both known and unknown threats and can adapt to the changing patterns over time. So for deciding the machine learning, what I've done is I've taken different papers and conducted literature review to decide on what machine learning models are best for the intrusion detection system. The same literature review is attached in my report. Next, coming to the goals of this project. The goals of this project is to detect the network intrusion of an existing network data as well as detect the intrusion real time and also applying different machine learning models, evaluating their performance and finding the best model for intrusion detection. Next, coming to the dataset. The dataset used is KDD Cup 1999 dataset, which is widely used benchmark dataset in IDS. The dataset consists of large number of network traffic records that were captured from a stimulated military network environment over 9 weeks. This data include both normal and abnormal network traffic, where the abnormal traffic represents different attacks lodged on the network. And based on the data, I've performed exploratory visualization. The first one is distribution of network traffic based on prototype type. Here, ICMP has the highest number of records and UDP has the lowest number of records. And next is distribution of network traffic based on flag type. So like the SF flag type has the highest number of records and OTH has the lowest number of records. And the image which is on the top like shows the different, what are the different flag types. And next one is distribution of network traffic based on the target. DOS attacks are the highest and user to root are the lowest. Next one is the correlation between the attributes. For the same, I have done an heat map. So here the dark in the bottom correspond to the least correlation between the attributes, and the light color in the top of the image on the right indicates that the attributes are highly correlated. And next thing is data pre-processing. So in data pre-processing, I've handled missing values, removed duplicates, encoding of categorical variables, and scaling numerical features using standard and min-max scalars. Feature selection techniques were applied to reduce the dimensionality of the data. Also, based on the data, like the heat map of the data from the previous slide, few highly correlated attributes are dropped. Next, coming to machine learning models. 13 different machine learning models were applied to this dataset, including Gaussian Naive-based decision tree classifier, random forest classifier, support vector classifier, logistic regression, and so on. And coming to the evaluation metrics. So I've used accuracy, precision, recall, F1 score, and ROC curve for my evaluation of the machine learning models. Accuracy means how well the ideas can correctly classify normal and abnormal traffic. Precision is the number of true positive results divided by the number of true positive results and false positive results. It means the accuracy of the positive prediction, indicating how often the predicted positives are correct. Recall measures the ability of a model to identify positive instances correctly. Sorry. F1 score is the harmonic mean of precision and recall, where 1 indicates perfect precision and recall, whereas 0 indicates the worst possible score. And here are the figures of the different metrics. First one is the accuracy. Random forest classifier, boosting classifier have the highest accuracy, and GAN and binary classifier has the lowest accuracy. Same is the case with the precision. Next one is the next figures talk about recall and the F1 score. Again, the random forest classifier, gradient boosting classifier have the highest recall score. GAN and binary classifier have the lowest recall score. Coming to F1 score, random forest, LGBM, which is light gradient boosting model, have highest F1 scores. So, like here, different metric, it shows the different metric values of different machine learning algorithms. As I told, these are the 13 different machine learning models which I've used in this project. And this is the ROC curve, random forest classifier, LGBM classifier, cat boost classifier have most area under the curve, indicating these models are better for the given ideas. Before coming to the conclusion, I would like to go through the code. So, like basically, this is the like coming to code. Like we can run this in Jupyter Notebook or Google Colab or any other Python notebook platforms. So basically, I would submit a Python notebook for this. And here are the required installation for the project: NumPy, Matplotlib, Cbon, Skit, TensorFlow, CatBoost, etc. So here I'm importing all the required libraries. Next, I'm reading the dataset, and this is the information about the dataset. So these are the different columns, and the data type are associated with the column. Like there are different data types like int64, float64, object, etc. So next, these are the different columns in the dataset. So what I'm doing is I'm appending an extra column which is target. So I'm doing this because like the attack types are very large. Like there are different things. So what I'm doing is I'm categorizing all of them into a single, like 5 different targets. Those are normal, DOS, user to root, remote to local, and probe. So this is all about mapping attack types to 5 different target types. So this is the code for that. And here we can see that there are 494 records and 43 columns in the dataset. And these are basic statistics of the dataset, the count of each row, the mean, standard deviation, minimum, maximum, the 25 percentile, 50 percentile, 75 percentile, etc. Next, what I have done is to do the exploratory analysis. I have found the categorical features, and it turns out flag, prototype, type, service, and attack type are few of the categorical features. And next, I have plotted, like I told in my presentation, I have plotted different graphs for the same. So this is a code relating to the visualization. So and I also to find the correlation I have plotted heat map and like I have dropped few of the highly correlated variables like num underscore root, srv underscore serve, server rate, etc. Also, I've also dropped service and attack type because they don't like it doesn't give much information. And like coming to attack types, I mapped it to a column called target, so we no longer need attack types here. So now after the mapping, like DOS has the DOS attack has the highest number of rows, which is 9390k, and user to root has the lowest, which are only 952. Next, like furthermore, I've done some more feature mapping where I have mapped protocol type to a number as well as the flag type also to a number. So that all the data types are either int 64 or float. I don't want the object data type in my data set. Next what I have done is I have mapped the attack type to the categories again. Like the normal is normal, and all the four attacks like DOS, probe, user like remote to local and user to root I've mapped into abnormal. Now abnormal is 396k and normal is 97k. Next, I've done like selecting numerical attributes column from data, and I've used standard scalar, min max scalar from normalization. Next, I have divided my data set into training and testing, which is 80 into 20% the standard. This is the code to test and train my models. So basically that to train the model and predict and find the accuracy, precision, recall, F1 score, etc. Here I have declared different models like Gaussian, Naive-Bayes, decision tree classifier, etc. Here I am calling the particular train and test method to find the accuracy, precision, and other metrics for different models. Next is like here it is cat boost classifier, the code for cat boost classifier. Yeah. Next here is a code for ROC curve. So I have calculated true positive rates and false positive rates based on the prediction of each model and plotted the ROC curve. Next one is the neural networks model. So I've used three neural networks here: shallow neural network, deep neural network, and convolutional neural network. And here is the code for calling the defined neural network models. Here I'm printing basically the accuracy, etc. of those neural networks. Next one is I have developed GAN. So for GAN, what I have done is I have done feature selection so that columns with higher impact on the target are only selected and trained, hoping for result, but it turns out that it doesn't have much impact on the dataset. And this is all the GAN logic. Next one is I've just plotted precision, F1 scores, recall, accuracy, and finally the ROC curve on this project. And here is the chart for the ROC curve. AUC here indicates the area under curve for the ROC. And finally, uh, The conclusion, like among these models, three are particularly effective: the random forest, LGBM classifier, and cat boost classifier. These three models have produced exceptional precision, recall, and F1 scores. This means they could accurately identify instances of malicious network traffic while keeping false positives to a minimum. Additionally, the area under curve for the ROC was also exceptional, further reinforcing their ability to detect and classify network intrusions. These results illustrate that machine learning algorithm techniques have greater potential to improve computer network security against attacks and cyber threats. Also, this can be done in real time, allowing security personnel to respond quickly to a potential threat. So, this is all about my project. I'll stop sharing and I'll end the recording. Thank you.